In just 9 days, that's right, we're down to single digits. 9 days, I will be on the ice in Antarctica with 4 Flerfs to see whether or not the sun does circles around us 24 hours a day, or if it does whatever the flat earthers think it might do. If it doesn't do what the globe says, then whatever. I'll go with them. I'll say it's flat. Okay. I'm recording a video that I'll have on my channel in that case. I'll also have a video on my channel if the sun stays up 24 hours a day. I'll pre-record these and I'll schedule them. You'll be able to see that they will be scheduled, and one of them will then become unscheduled and the other one will go live. You'll see. So be sure to follow my channel to subscribe for when that happens, so you can see whether or not the sun sets or does whatever flat earthers say, or if it goes in circles just as the globe predicts. Now I've got a couple updates to give you, a couple things I'm going to talk about. This will be a little bit longer than my other daily updates, but it'll be worth it. First, I'd like to say that experiment number 2, the dip compass, I had tested it in the cold and it stuck a little bit. The magnet there stuck a little bit, and I've fixed it. I got some lubricant that worked pretty well in the cold. I left it in the cold overnight, and it was like 9 degrees Fahrenheit here in Minnesota, so it got down to that cold and it worked well, although it may be even colder than that in Antarctica. The lubricant I used is rated for -100 Fahrenheit, so it should be just fine there. So that is experiment number 2. If you look at my website, mctoon.net/TFE-experiments, that's experiment number 2, is the dip compass and the magnetic field of the Earth. Now, I also mentioned in a previous video, experiment number 8, the distance between lines of longitude, and I had a little video from Baron Rutledge. Now, he made an error in his computations, and several people messaged him, several people messaged me, and in fact, he did make an error. Now, he's acknowledged that, and that's what we do. We make mistakes, we acknowledge them, and then we improve. Now, what he has done is fix it and all that, and he didn't fix it. I mean, he understands. So here's the challenge. All of the corrections came from people that are globers, normal people. Here's my invitation to flat earthers. Go watch that video and find the error and send me paper written down of the correct analysis and maybe point out his error, or a video. I'll feature you right here if you do it. Whichever flat earther. Oh, I'm getting a phone call. Just a second. Oh, it's just a scammer. Never mind. Anyway, whoever has the any correction, first one to send it to me, I'll feature you. All right, flat earther. You need to be a flat earther. So, will I get any flat earthers that go and find the error in trigonometry? I have my doubts, because I don't think that there are any flat earthers that understand trigonometry well enough to identify the error in that. I don't think flat earthers understand middle school math for the most part. But you could prove me wrong. Okay. Another thing, I got the Frisbee that I'm bringing to Antarctica. We ordered new Frisbees for the team, and I yeeted one of them to bring down to Antarctica. Normally we don't like the orange ones for practice or for games, because the plastic's a little different. But on the ice, we do want the orange. So that's what we'll have. So if anybody wants to play, there's 9 of us. We only need 8 to have a decent game of 4-on-4 with 1 sub. So hopefully we can have a little game there. Anyway, next, experiment number 1 is about the sun circling overhead. And there have been flat earthers, believe it or not, that have claimed that there are multiple suns, as if, how would you not notice that the one sun goes away somehow and another sun appears in its place? We would notice. But flat earthers, I don't know. I think they're not quite bright enough to realize that people would notice. Somehow the sun got swapped out and there would be a different sun. Some people have suggested there's 4 suns or 2 suns, or maybe, who knows? When you're going that crazy, And it doesn't matter. You've crossed the crazy line. So any number is the same as any other number. Oh, another scammer, this time from Spain. Look at that. I get them all the time. Part of my job is to investigate investigate scammers, email scammers. They call this phone. Anyway, so the sunspots is how we can identify that, because sunspots are unique per day for the sun. And if you have a solar filter, you can see them clearly. So what should we do? Well, in Antarctica, I will have my P1000 and a solar filter, and I will take photographs of the sun often, maybe every hour. We'll see. Not super regular necessarily, but definitely I will be taking photographs of the sun at local solar midnight, which is when the sun is at the lowest elevation in the high, if it's circling around overhead, which everybody knows is going to be what we see. Flat earthers even know that. That's why they're scrambling and redefining how flat, right? They're scrambling. It's like cockroaches with the lights on. It's fantastic. I love it. Anyway, we know that, and the globe prediction is that it will be 13 degrees in angular elevation. So once we definitely will see that, I will be taking a photograph of the sun, exposing it properly for sunspots, and I'm asking you, good people, to do the same thing. So in Punta Arenas, we will be at Chilean time, which is 3 hours offset from UTC. And when we're in Union Glacier in Antarctica, we use the same time zone. Even though that wouldn't quite be the correct time zone there, it doesn't matter because the sun's up all the time, so they pick whatever time zone is convenient for them. And since Union Glacier headquarters are, the local headquarters are in Punta Arenas, they use the same time zone, just by convention. So we will be using that. So at 2:30 a.m., Punta Arenas time is when the sun will be at 13 degrees in angular elevation. So wherever you live, you can now offset from that, and you can look it up yourself. Timeanddate.com has tools to do that. In fact, there's one called the time zone meeting calculator. Just use that. Put in your time zone, put in Chilean time, and then do 2:30 a.m. and see what time it is for you. Then, if you will see the sun at that time, which half of the earth won't but if you are in the half that will be illuminated, get a photograph of the sun with a solar filter on it. Make sure that it's exposed well enough that you have crisp sunspots. So test this ahead of time if you want to participate. And then I'm going to ask you to send me an email with the photograph, the full size photograph with all the metadata and everything on it. That one I would love to have, along with the details of where you were and the camera details. So what does that mean? Well, what I like to do is on the iPhone, I'll pull up the Compass app and I'll just take a picture of the Compass app that gives me the location, and you need to make sure you turn it on, the location in settings. And I'm sure there's things in Android. If somebody has an Android and you want to comment, I'll pin your comment on instructions on how to do that for Android. And then also for the next thing I'm going to be asking, include the details of your camera, the model number, and details about the lens if you have an interchangeable lens. And if it's a zoom lens, I'll ask that you try to zoom in all the way, or at least know precisely how far you're zoomed in. Typically, if you're zoomed in all the way, it won't be, unless you have a really strong zoom, the sun won't completely blow out the frame. So like the P1000, you zoom in all the way, the top and bottom are cropped, but the width is not. And that's what I really want for this next one. So anyway, give all those details, send it to sun@mctoon.net. I have a special mailbox dedicated to that, and I have a curator, a person that's going to be curating them. It won't be me, but this person has agreed to facilitate that, and will be publishing them on the Flerf wiki, flerf.info. There's a page dedicated to just the sun observation. So you can be on that website. Just email the details to to sun@mctoon.net. And of course, it's a publicly accessible Wikipedia site. So if you You can edit the page yourself. It's already on there. I think it's just, I don't know. You can find it. Sun width. So look it up. Go to flerf.info and find the page. I created a page already. So you can do that. Okay. That's for experiment number 1. Now, experiment number 7 on TFE-experiments on my website is the angular width of the sun. Now, this is really, really powerful because flat earthers, when you ask them, how do the seasons work? They say, oh, well, it's a disk and the sun goes in circles over the disk. That's what they say. And how do seasons work? Oh, well, it does tight circles in the northern summer and wider circles in the northern winter. And it's the southern summer then. Okay. Very specific claim. We can test that. Now, on the equinoxes, the 2 equinoxes, I personally measured the flat Earth mandatory height of the sun over flat Earth because I'm in Minneapolis. I'm at 45 degrees north latitude. And at local solar noon, the sun was due south. And the angular elevation of the sun was 45 degrees. Well, that creates a 45, 45, 90 triangle. And since I am in Minneapolis, 5,000 kilometers from the equator, the sun is directly over the equator. That means that we have the base here and the height here have to be the same. 5,000, 5,000. The sun must be 5,000 kilometers high. Now, flat earthers, if I'm wrong on this, sometimes they disagree with my application of geometry, math, physics, optics, but they don't provide the right method. So I'm just asking if I got that wrong. I don't want to straw man you. Give me the correct method. Give me the correct height of the sun over flat Earth. If you don't give me the correct method, you cannot cry straw man because all I've done is apply your claims. So we know the sun must be, according to flat Earth, 5,000 kilometers high. And of course, this is confirmed through Eric Dubay, who says it's about 3,000 miles, 5,000 kilometers and 3,000 miles. Very close. Samuel Rowbottom said that. You get the same from what's his name? Gleason. Gleason said in the same range. So this goes historically with flat Earth claims. So again, no straw man. This is your model. And if it's not your model, happily, I will amend my application of your model. You just need to provide it to me. So now what I'm going to do is I'm going to show how we can compute the angular size variation of the sun mandatory for flat Earth. So this is the map that flat earthers have referenced for well over a century. Many flat earthers have this exact map on their wall behind them while they're doing live streams in poster form or things like that. So this is exactly the thing that flat earthers reference all the time. So here is where we will be down here in Punta Arenas. This is what I'm doing the computations for at the time. But when we're in Antarctica, we'll be down here at 80 degrees south latitude. So close to the claimed whatever's here, ice wall or ring or edge or whatever. Different flatties have different ideas. So when we're in Punta Arenas at local solar noon, the sun will be about there. This is somewhat close to it. So how far is it from Punta Arenas to the point on the surface of the Earth directly beneath the sun? That's called the GP of the sun right here. Well, because Punta Arenas is at 53.2 degrees south and the GP of the sun will be 22.9 degrees south, and there's just over 111 kilometers per degree latitude. As it states, let's make this clear. This map gives a guide right down here. You can't really see it, but it says 60 nautical miles to the degree latitude right in here. And that is 111 kilometers per degree latitude. So I'm going right off of the claims on the map. Don't think I'm strawmanning. This is exactly your claims, flat earthers. If you disagree, again, just send me an email with the correct details, mctoon@mctoon.net, and I will happily update them. So here is where we will be. Here's where the sun is, and we know the distance there is then 3,366 kilometers due north by just doing the claims from this map. And how high is the sun? Well, as I said, the sun is 5,000 kilometers high, as I measured from Minneapolis to when the sun was over the equator myself. I did it myself, 5,000 kilometers. So I'm going to use the same number, 5,000 kilometers here. So the sun is 5,000 kilometers high. And so we do a Pythagorean theorem. We have the base here. We've got the height there that we know what's the straight line diagonal distance. Well, when you solve for that, you get 6,025 kilometers straight line distance. Okay. And at local solar noon, we will confirm the angular size of the sun, but I expect it to be 1/2 of a degree. And that's what is normally measured, normally, always. Anyway, so now we'll take the sun and we'll say, well, let's move it 6 hours later. Well, 6 hours later, the sun will be over here. And then we can do another measurement. This is a fantastic way to do stuff. We can do real science here, right? So what's the distance from here to here? Well, we can solve that distance using the polar distance formula, which is just a polar coordinate version of the Pythagorean theorem. And then we know that the elevation is 5,000 kilometers high. So we can solve that distance there. And that distance is 20,866 kilometers. Now, all the more detailed math is on my website. Again, you can check that out, see if you think I got it right, or correct me if I got it wrong. But Flatty's lacking a correction, you're not going to get anywhere. You need to actually put on your big boy pants. So now what do? We say, well, we know that when the sun is at local solar noon, it's 1/2 of a degree. I'll verify that myself. How big must the sun appear when it's farther away? Remember, when things are far, they're smaller.
Okay, one last time. These are small, but the ones out there are far away.
So how small? Well, we use the angular size formula, which is theta equals 2 arc sine d over 2d, where theta is the angular width of the sun, d is the linear diameter of the sun, and capital D is the straight line distance to the sun. Now, you may sometimes have seen the formula as theta equals 2 arc tangent of d over 2d, but because the sun is a spherical object, then there is a more correct formula, the arc sine instead of the arc tangent. So now that gives us a linear diameter of the sun for flat Earth of 52.5779 kilometers. Now we can plug that in for the farther distance here, the 20,866 kilometer distance, and the prediction for the sun for the angular width is 0.14 degrees. So that's what the flat Earth requires, is that the sun has shrunk from 0.5 degrees here, 0.5 degrees there, to 0.14 degrees there. That's less than half. We can test this. And when I say we can test this, I mean you can test it too by, again, taking a photograph of the sun with a solar filter, identifying the location that you are, and then sending it to me, sun@mctoon.net. Give all the details I mentioned before, and we can compare your location to the mandatory required angular size of the sun, angular width of the sun, for the different positions that you are in. This is fantastic science. It's going to be fabulous. See, if we know the details of your camera, we know the focal length of your camera, we can get the angular size of the sun when you have a good solar filter on the sun. It's super cool. Flatties have said that the sun changes sizes, and they show these awful videos where the sun doesn't have a solar filter and it's overexposed and it's glare, and you see the glare changing size. That isn't a measurement of the angular size of the sun. That's a measurement of the angular size of the glare. Come on, Flatties. You're ridiculous. Anyway, you get to participate in this. I look forward to that, and the analysis that people will do is going to be fantastic. And will it confirm that the Earth is flat, or will it confirm that the Earth is a globe? Well, I know what I think. Anyway, I didn't mention what is the globe prediction. Of course, we need to have both the globe prediction and the flat Earth prediction. Well, the angular size of the sun for the globe is based on the distance between the Earth and the sun. The distance between the Earth and the Sun is about 150 million kilometers, 93 million miles, and it varies by a really small amount. So the annular range of the predicted size change of the Sun, over the course of an entire year, from when the Earth is closest to the Sun to when the Earth is farthest from the Sun, that prediction is 0.5242 degrees to 0.5422 degrees. A total of about 2/100ths of a degree in angular size change over the course of a year, six months apart. So over the course of 6 hours, that angular size change is 0 degrees to the nearest 10,000th of a degree. I don't know exactly, people. If you feel like it, go ahead and comment below the globe prediction angular size change. Do the math for it in the comments. I love seeing the globers do the math for the globe, right? Because we're not scared. We're not scared of actually doing the applying the globe model and testing it, because every single time we test it, it works. Anyway, be sure to subscribe and watch for, we're going to be on the ice in 9 days. I leave in just a couple days, and I got a whole bunch of more stuff to do at home before I leave. So I'm going to get back to that, and you just make sure that you subscribe.